Okay, so we're going to pick up from where we left off last time, which we finished doing orbital diagrams following the three rules. Now we're going to get into a new type of address system. Right, so addresses, like a normal street address, lets us know the location of a building anywhere on Earth. So we'll just take a famous address, we'll say the White House. White House's address is 1600 Pennsylvania Avenue, and that is in Washington, D.C. Washington, D.C. tells us the city that we're in, so that's a very large area, right? So we're starting off very general. Pennsylvania Avenue is a street in Washington, D.C. We're getting a little bit more specific, a little smaller area now. And then the address, which is 1600, the house number, gets us to a very specific location on a specific street in a very general area of a city. Electrons work in a very similar manner. The way that electrons do this is by using something called electron configuration, which is just a listing of how many electrons there are in each sublevel. You start lowest energy, you go to highest energy. The number of electrons is always written as an exponent. Okay, so if we take fluorine, if we go back to our orbital diagram for fluorine, there are 2 electrons in the 1s sublevel, so I say 1s, 2. 2 electrons in the 2s sublevel, so 2s, 2. And then 5 electrons in the 2p sublevel, so 2p, 5. Right, so we have our very general area, which is the shell number 1 or 2. We have our more specific location, which is the subshell, S and P. And then we have the number of electrons, which tell us where on the street they are. So this is how we do an electron configuration. Again, the larger the element, the longer this is going to be. Once you get the hang of doing this after a couple of practice problems, it's not hard, it's just more time consuming than anything. And by the way, you don't want to get me angry, because when you get me angry, that's when I can tell you, oh, please draw the orbital diagram for livermorium, element number 116. Right, so I would highly suggest being nice. Now, jokes aside, I do want to give you a serious warning before we go any further. Electron configurations can easily be looked up online through most any source. I'm going to tell you right now, do not look them up. There are reasons for this. Okay? Most common reason is that a lot of elements are exceptions to the 3 rules that we went over. I'm not going to tell you which elements are exceptions to those rules, with the exception of one in a little bit, but there are a lot of exceptions. If you look it up online, you will be writing a different electron configuration than what I am expecting from you. If you do this, automatic 0. Okay, so do not write those down for the exceptions. Also, one other thing you'll notice if you look things up online is that they write the subshells in different orders. They use what online was called spectroscopic notation. So instead of going, for example, 3p6, 4s2, 3d10, they will go 3p6, 3d10, 4s2. So slightly different order on some of those sublevels. It is extremely easy to catch. Find somebody doing it at least once every year. Please don't be that person. I can guarantee you that there will be exceptions on tests and quizzes. So that's what I'm going to use to see if you're looking them up. Alright, as an example, what I want you to do is pause the video and draw the orbital diagram and give the electron configuration for the element copper. Copper is number 29, so there are 29 electrons to draw. Okay, so hopefully you've attempted this. So we're going to start off with the orbital diagram first, because that will help us write the electron configuration. Okay, so we have 29 electrons to put in. We're going to start off with 1s because that's our lowest energy sublevel. 1s has one orbital, so I draw a line, 1s1, 1s2. 1s is filled, I move on to the next one, 2s, single line, 2s1, 2s2. After 2s is 2p, p's get 3 lines, 2p, 1, 2, 3, and then come back 4, 5, 6. This right now is 10 total electrons, so I'm going to count from 10 here. After that, we have 3s, draw the line, 11 and 12, 3p, 13, 14, 15, then come back 16, 17, 18. After that is 4s, 19 and 20. After 4s comes 3d, so that's 5 lines for a d. 21, 22, 23, 24, 25, come back, 26, 27, 28, 29. So this is the orbital diagram for copper. If I write out its electron configuration, we have 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d9. Now, I told you I was going to give you one example of an exception. Copper is an exception. If you look copper up, what it will say is instead of 4s2, 3d9, it will be 4s1, 3d10. Okay, copper's an exception because for some energy-based reason, 3d10 is more favorable than 3d9. So if you wrote 4s1, 3d10 as an answer to this on a quiz, that's how I know you're copying it from somewhere. Right? I'm not trying to hide this from you. I'm trying to get you to avoid doing this. All right, so this is electron configuration. We're going to have plenty of practice writing and drawing these. So I will see you guys in class.